We have a smart contract on Remix deployed on the Ethereum test network. Python is going to check for events, send it to Arduino, and then hopefully we should see a buy signal. Let's go ahead and click on buy and then confirm the transaction. Once the pending is done, we should see this thing turning green. So let's check it out. Pending, come on, please work. There we go.
Hey, how's it going guys? My name's Daniel, aka HashLips, and welcome back to my channel for this exciting video, where today I'm going to show you how you can control a servo via a smart contract. Yes, it sounds crazy, but we can do that, and it's some sort of an IoT project, but instead we are going to be using the blockchain. So what you've seen before is the result. We're going to get to that. But in front of me here is a digital representation of what we're going to build. Firstly, we're going to need a smart contract, and we're going to do this on the Ethereum blockchain on the Sepodia test network. Then we're going to write some scripts in Python, which is going to observe for any events from this smart contract. Python is then going to be able to communicate with the Arduino and make the servo move. And that is essentially what we are going to build. Now, this is very exciting because once you understand the core technologies involved to get a component, an electronic component to move via a smart contract, man, you can do anything. And with so many NFTs and smart contracts out there, you can even use existing ones. So it's going to be very exciting to see what people do with this in 2024. If you're going to like and use this video, please give it a thumbs up. And if you haven't subscribed yet, do so, because 2024 is going to be amazing. All right. So I would like to start off by saying that I'm not an expert when it comes to electronics. However, I have done some research, so I managed to build something cool for you guys today, and you can follow along as well. Also, when it comes to Python, we can do this in JavaScript as well, using a library called Johnny5. But there is a bit of a problem with the serial port reader working with the Johnny5, and since that version update, I've just been struggling to get that to sync. So instead of me using JavaScript and having you struggle, let's rather use Python today. Okay, let's get going to the prerequisites. Now, this part's completely optional, but I thought it would be nice to find an interesting mechanism for my servo. So I found this one from Potent Printables, and it's pretty amazing. So I was using the smaller version for my small servo, and it's basically a mechanism that can move, up and down in a horizontal or vertical fashion. So I downloaded this, and then I took these files to my Creality slicer, and I just dragged them in, sliced them all up, made sure that they are good for printing, and then I decided to go ahead and print these. So the thing is that you do not need to follow along with me here. If you do not have a 3D printer, you can still just move the servo or turn on an LED by itself. I just thought it would be nice for this project to be able to have these. If you do not have a printer, just watch along. So here I am printing the bracket in my time lapse. I thought this would be cool to add so you can see the process in the works. The bracket didn't come out that nicely. You can see the print lines aren't that great, but it's okay. No one's going to see this thing ever. So we moved on to this track, I guess you can call it. That came out pretty nice. I left this clicking sound in here for you guys, and this came out pretty good. So I'm very happy with that. And lastly, we needed a gear. So this is the small gear. And of course, you'll need some screws, but I'm going to show you the complete list right now. So to start off, you'll need some sort of servo. You can use any servo. This is a cheap and small one that I found. And usually with a servo, you get these 3 wires. The brown is for the ground, the red for the 5 volts, and then I believe the orange is a digital input pin. We'll need an Arduino. This is a generic Arduino Uno. So just to show you, any Arduino would work. I do have the original one, It's encased in this Perspex case that you see over here. So I'll be using the original for this, but they're generally the same. So just to show you can use any one that you have. You can pick these up on Amazon. We'll need a cable to connect the Arduino to the machine, some jumper cables as well. And then the totally optional part is the bracket, the gear, and of course the little rack. So like I said, if you don't have a 3D printer, you can do this project without these. You'll need some super glue and screws. The super glue is literally just there because I just didn't have the correct screws, but I made it work. So you'll see it. So let's start off by building everything. Now I'm not going to show the full process. I'll make it a small window here on the left. But essentially, take your servo, take a screw, and then go and screw the gear into the servo's head at the top. Now I believe I did this the wrong way around, but there's a specific reason for that. I'm not so sure if it was the levels that I'm working with, but I had to match up the track and that gear. So this worked for me. So please don't give me grief in the comments for this. As I said, I'm not used to working with these components, but I'm very proud of how it came out. So essentially what you want to do at this point is make sure that this track is smooth in its bracket. And once you feel that it's smooth, you'll see the bracket actually looks burnt. I actually took a lighter and burnt it a little bit just so that the PLA gets melted and can slide that track through smoothly. Then you align everything up, make sure that everything fits well, and then start putting in your screws. Now I'm not going to show the full process, so there it is minimized. I'm going to continue with all the software prerequisites that you'll need now. For the software prerequisites, it's pretty straightforward. You'll need the Arduino IDE, so you can just download that from the Arduino website. Then we'll also need Python, and specifically Python 3.8.10. Currently, the latest download is 3.12.1, and the reason why I want to download the older version, so you can go to Downloads and then All Releases, is because one of the libraries works with the older version. So just go down here and then search for 3.8.10. And then download that one and follow the instructions. And lastly, we'll need an IDE. I love using Visual Studio Code, so get this as well so we can write some Python. Now, once you have installed Python, go ahead and open Visual Studio Code and create a folder on your desktop or wherever and open that folder in Visual Studio Code. Then at the top, click on Terminal and then New Terminal. Now, just to check if everything is working, type in Python 3 -- version, and we should see that the version is 3.8.10, so we know that this is now already set up. Now, for this next part, we need to deploy a Solidity smart contract on the Sepolia test network. So if you are not familiar with writing Solidity and getting MetaMask set up, I do have a great playlist of about 50 videos of how you learn how to work with blockchain technology. So go and check it out if you do want to know more about this next part that I'm going to be doing. I'm not going to teach Solidity, we're just going to be pasting the contract that's needed for this tutorial. So head over to remix.ethereum.org. This is a great IDE for deploying smart contracts. Here on the left-hand side, we're going to click and create a new workspace. I'm simply going to select a blank one and we'll call this the servo project, like so, and then hit OK. Now that we have our project, what I'm going to do is create a new file and we're going to call this servo contract. Okay, it's not a creative name, but it is going to be dealing with a servo at some point. In the file, we're going to place our simple smart contract, which is a servo contract, the same as our name. And essentially, we have a buy and a sell event. Like I said, if you don't know what events are, go and check the Solidity course. However, the most important part is that we have two functions, a buy and a sell function, and each one triggers its respective event, buy and sell. And this is what we are going to be listening for on Python to trigger our servo. At this point, we're going to deploy the smart contract. If you don't see the artifacts, just refresh the page so that this could be generated. However, make sure that we have MetaMask installed and also that we are on the Sepolia test network with some Sepolia test ether. Then we can head over to the deployment section, and here in the environment, I'm going to select Wallet Connect, and I'm going to connect to my MetaMask wallet. And there it is. We can verify that we are on the Sepolia network. We need to make sure that we have the correct account or the contract, and then we're going to click on deploy. Now we should wait for MetaMask and confirm this deployment. And then once this is done, we should see our contract being deployed on the actual network. We can also check this on Etherscan, but we can just work with it here. So we see our contract, we have its address, and we have the buy and sell functions. And if we want to verify, we can copy the address, go to Etherscan on Sepolia, and then we can just search for our contract, and indeed, here it is. All right, we have set up this section, so we can just leave this as is. We'll come back to this on a later stage. I want to take a quick break and just say that if you are enjoying these videos and you want to form part of an open source community, head over to hashlips.io, scroll down until you see the Discord, and you can go ahead and join. The Discord channel is filled with creative individuals building cool things and just having some fun. Always do your own research there because it is completely open source. However, it is also a great source if you want to ask some questions or you're getting stuck with your coding adventures. Back to the build, I took some foam board and cut out a hole. I took another piece of foam and spray painted one part red and one part green. And this is to indicate the buy and sell signals. So essentially, I would place this behind this slit that's cut into the foam board, and then the servo should move this kind of up and down. So I need to attach this in some way to the servo's axis at the bottom. This thing was in the way, so I wasn't sure how I was going to get this to stick. So I decided to just break this off. Probably not the best way. I should have used a saw, but it works. So here we can see this is my plan. I was going to stick this part at the back. Now this part is crucial because you need to also measure how much that servo can move, because a servo can only move from 0 to 180. And what I've done is I've realized that the hole that I've cut is a bit too big. So I made a separate piece of foam board with another slit in it to position it correctly based on how much the servo can actually move. So this is the final part. I think it came out great. I even made some fins for it to stand on, some support so it can stand freely. And I did some tests. So this is something that you need to play around with. But once it's done, we're ready to continue. Okay, so make sure that you have your jumper cables connected to the servo. It needs to be the corresponding colors. We're going to start with the red one and plug that into the 5 volts port on the Arduino. You'll see it's there at the top. Now, the next port that we're going to plug into is the ground. So that is the brown cable into the ground. And then I hope you can see this pretty well, but there's more grounds that you can choose. And then lastly, we're going to take the orange and choose a digital pin. I'm just going to choose number 9. And this is the setup. Okay, so now once you have that, plug your Arduino into your machine and let's set up the software. Next, what you're going to do is open up your Arduino IDE that we have downloaded. So it's going to look like this. The first thing that you'll need to do is go to Tools, and then in the port, you need to make sure that you select the port that your Arduino is plugged into. So we can verify that this is our port. And make sure that you also have selected the correct board for your port. All right, so now what we're going to do next is click on File, Examples, and then down here on Fermata, go and select Standard Fermata. This will pop up a whole bunch of code that's going to be pushed to the microcontroller. This is important because Python cannot directly manipulate the Arduino, although this sets up the Arduino to have basic functionality that Python can interact with. So you can close the previous window, and having this one open, the standard for Marta, you can go and verify it if you want to. But once this is verified by clicking on the check, you can click on upload. Now, when you do this, you'll see the TX light flash on your Arduino, and that means that this code has been pushed onto the microcontroller, and now our Arduino is ready, so we can just go ahead and close this all down. Now for the most important part. Let's head back to Visual Studio Code, and in our project folder we're going to create a new file. I'm just simply going to call this servo.py, and this will be our script that we run whenever we want to start listening for the events. Now, I'm going to paste this code and not type it all out because I think it's better for me to explain what's happening instead of writing this and then having you type along. So I am going to pause the video here for you to copy ahead. And remember, this is Python, so indentations such as these are very important to get right. This is just how the language works. So I'm going to pause here all the way to line 33, and then all the way from line 33 to line 61. This is what you can go ahead and copy. Now, I know most of you are going to tell me, where's the code? I believe that it's really important for you to practice writing code. You do not need to write all the print statements. This is just here to help us see what's happening in the terminal. But let me cover what's happening in this piece of code. Now, the first 4 lines are our imports, and the libraries that we would need to install is the Py4Marta and the Web3 library. So what we could do is we could write Python 3-m to run it as a module, and then we can just say pip install Py4Marta. And once we've done that, we would install this library. Now, I believe I already have this, so I'm just doing this so that you could see. But in any way, you would install this like so. So I'm just going to do that, and then next you would run the Web3 one. And once you are done, we can continue. Next, let's go ahead and clear the terminal. I'm going to click Command K to just clear that out. So in the next line, we're looking for an Infura URL. This should be our gateway to the blockchain. So if you go to Infura, you could just sign up, and then on API keys, you can go ahead and create a new key. This one would be for our servo project, like so. And I'm going to show this key, but just hide these keys from people. I'm anyway going to delete this once I'm done with the tutorial. So under Ethereum, we would like the Sepolia network, and then click on Save Changes. And now I should get this URL that I can copy, and then we're going to go back to the code and paste it right here. Again, just reiterating, don't show these kind of keys to anyone, any public person. This is sensitive data, but for this purpose of the tutorial, I'm anyway going to remove it afterwards. All right. And now we would need our contract address. Remember, we deployed our smart contract, so we just need its public address over there. And that we could simply get from Remix. Here's our contract. We can copy that over there, or we can get it here from Etherscan, either way. So let's go and paste that here. Going on, we can see that we would need an ABI file that we are going to read and load the ABI for that smart contract. So what we could do is create a new file and call it abi.json. And then all we need to do is go to Remix. And if you go to this tab on Remix and you have your contract loaded, here we can simply copy the ABI by clicking there. So we can go back and then just paste it in here. Okay, save the file and close this down. Now that we have the ABI file, the program can read it, and then make sure that we can actually create the contract over here. So the next steps is, firstly, we connect to the blockchain. Then we create an instance of this contract so we can do some reading from it and observe what's happening with the events. Then we need to set up the Arduino connection. So firstly, we'll need the port. Now, where do we get this? Well, remember when we connected the Arduino and we looked at if the port was connected, this is the exact same name. So you can either look at this on the Arduino IDE, or in the terminal, we can run this command on Mac. And if we can see the Bluetooth, and we can also see this port over here, which we can just place. So yours would be different. So just make sure you have your port entered in there. Then we go ahead and set up a board using this port, and we tell it basically that we are going to use pin 9 for our data that we need to send to the servo. We set up a function that takes in an angle, move servo, and it moves it to that angle and then sleeps. And this is where things get exciting. We specify a by topic event as well as a cell, and we base it off the hash of this string, which is the identity of that function in the event. Now, how do we know that this will match? Well, I'm logging this out so we can see anyway, but if we go back to Etherscan, we can click on events, and we can either fire an event or a function here, but I'm just going to jump back to Remix, and on the contract, I'm going to give it a by. So I'm going to call this by function, confirm it. And once this is done, once this has gone through, we should see an event kick off, and it should be our by event. So let's go and check that out. And indeed, here it is. So we could see that 2 minutes ago, there was this by event that got kicked off, and the topic over here should match that hex that we have in our code that we have stored here. So essentially, we're going to be checking if these hexes match to a by or a cell, and then perform some sort of action. In this case, in this whole code, we are simply reading from the contract. So when we are instantiating the contract over here, we're probably not using it for now. But later on, you could actually have actions that you do in the real world, like clicking buttons, actually perform and kick off things on smart contracts, the other way around. But for this example, I would just like to put everything here so you are geared up for whatever you want to do in the future. Okay. So moving on line 33, what we are doing here is we are checking the last processed block. And this is important because in our while loop, we're going to loop and get back the latest block and then perform the buy and the sell orders. Sometimes a buy and a sell might take place, and then when we read it again, the servo would go up and down because it essentially kicks off the buy or the sell twice, and we don't want that. So we need to kind of make sure that we know what the last process block is, and then we go ahead and loop over everything. So we start the loop, we filter out the latest block, and then we check if there was a buy or a sell event. If there was a buy, we're going to call our function, move the servo 180 degrees. If there was a sell, we're going to move to 0. And then we're going to sleep and reiterate. So nothing is happening right now. All we need to do is run this script. So in Remix, we can do this in Etherscan or Remix. We can kick off actions on the smart contract. So I'm going to say that I want to buy. So let's click on buy. And here I'm just going to confirm this. And before this goes through, it's pending. I'm going to go to Visual Studio Code to see if it's being picked up. And let's see, it should pick it up. And then once it finds this event, we're going to see a move in our servo. And there it is. How freaking cool is that? It picked up a buy event and our servo moved. So I'm extremely proud because I think this is going to open so much potential for people in the Web3 space. I think there's going to be so many cool projects that can get built like this. Let's go and do a sell. So I'm going to kick a sell off, confirm that. And we just wait for the log to happen. Now you can make the loop quicker, but with Ethereum, it only goes through on a certain block. So I think 5 seconds is fine to wait for the log to actually go through. It doesn't have to be instantaneous, although you can make it instantaneous as well. And there, the cell goes off. And this will continue to work as long as you run the program with Python and your Arduino connected. I really hope you guys enjoyed this video today. I really put a lot of energy into making this video for you guys. So please subscribe, give this video a thumbs up, and comment what you enjoyed the most and what you would like to see. Do you like these type of videos? Would you like me to build more cool things? Let me know as well. Other than that, I hope you have an amazing day and Happy New Year's to you all.